So 2 over 11, that is repeating. And as long as you have a repeating decimal, you also have non-terminating. It keeps going because it's repeating. 9 over 7. Repeating or non-repeating? Non-repeating and terminating or non-terminating? So if we see this many decimal places, I think this one's only showing you 8. So sometimes if you have a number in front of the decimal place, it'll only show you 8. So 8 or 9. That would be, it's going to keep going. Okay? So it has only a certain amount of spots on the calculator to show you a digit, an answer. So this would be non-terminating. Okay? Let's skip D. Let's go to E. Square root of 8. Repeating or non-repeating? Non-repeating and non-terminating. Last one. 0.4. That's it. So that would be non-repeating, but terminating. It ends. Does not keep going. Okay, easy. Review. Should be review, right? Turn the page. All right. This is where it gets fun. It gets fun. So rational and irrational numbers. We're going to look at the number system today. Classify all our numbers again. You have to be able to look at a question and know if it's what number systems it belongs to. So there's two under the real number systems. So all real numbers, and real numbers are what we study. There are something called complex numbers or imaginary numbers, and you don't study that unless you're going to calculus. But real numbers is all the numbers that we work with. Your calculator can only handle real numbers. Okay, so all real numbers are either going to be rational or irrational. Now the symbol for rational is a Q, because it has to do with a quotient, and we'll talk about why. And the symbol for irrational is a Q with a line on top. And that line in math means not. So not Q. So it's either rational or not rational. Not Q. Okay? So that's why the symbol is with a Q with a line. So it's either it is or it isn't. There's two types. I'll start drawing it on the board. The root of the word rational is ratio, meaning it can be written as a fraction. So rational numbers can be written as a fraction. Okay, so, and that's what it says. Decimal numbers which repeat or terminate can be, then those are going to be, let's highlight that. So decimals that repeat or terminate, they can be written as a fraction, and they're called rational numbers. So anything that can be written as a fraction is going to be a rational number. So it can be written as A over B as a quotient, right? That's where the Q comes from. And if you have decimals, as long as they repeat or terminate. Oh, this is in the wrong spot. Sorry. Here you go. Rational can be written as A over B. And then decimals, they have to repeat or terminate. Then it's a rational number. Okay, then it can be written as a fraction. Irrational would then be the opposite of that. So an irrational number cannot be written as a fraction. And if they're a decimal, we know that they can't be written as a fraction if they have to do both. Both are non-repeating and non-terminating. Okay, So non-terminating, non-repeating. Cannot be written as a fraction. So decimals that are non-repeating and has to be both non-terminating. Okay? Then it's going to be an irrational number. Irrational numbers also include pi. There's some special symbols, right? You know that one. Everyone knows pi. It's like the most popular irrational number out there. It's like the celebrity of irrational numbers. But also square root of non-perfect squares. So square root of non-perfect squares. So, for example, square root of 2 is irrational because 2 is not a perfect square. Give me a number that's a perfect square. 4, 16, 9, right? Those are perfect squares. When you square root that, you get an actual whole number. So that's going to be known as a rational number. But if you square root it and it gives you a decimal that's non-terminating, non-repeating, you know it's irrational. Okay? Square root of non-perfect squares. And the same goes for cubic roots of non-perfect cubes and so forth. Squares. There you go. Okay, so we're going to look at each one of these, and we're going to classify them as either rational or irrational. So all real numbers, and R is the symbol for real numbers. It's like a fancy R actually usually. Okay, so real numbers are either rational or irrational. So the very first one, 1.493. Is that going to be rational or irrational? So let's look at the decimal. Remember, rationals, if it's a decimal, it's either repeating or terminating. Is this one doing one of those things? It's terminating. There's no dot, 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 right? So since it's a terminating decimal, it's terminating, therefore it would be rational. Now root 5, we can type it in our calculator. We don't have to, but you can see if you type it in your calculator, is it repeating? No, non-repeating. Is it terminating? So if it's non-repeating and non-terminating, it's irrational. Irrational. Okay, what's C? What type of decimal is that? Repeating. Non-terminating, but repeating. So that's good. If it's repeating, as long as it's repeating or as long as it's terminating, it'll be rational. Yeah. What is the square root of 81? Yeah, so but yeah, the negative. So what is the negative square root of 81? Negative 9, because square root of 81 is 9, and the negative's on the outside, so it stays on the outside. We just can't square root a negative. If the negative's inside, then we have an issue, right? Cannot do that. So that equals negative 9. Technically, is that decimal terminating? Yeah, there is no decimal. So it obviously was terminating, right? Or another way you think of it is, can that be written as a fraction? Negative 9. Yeah, negative 9 over 1 or negative 18 over 2. Right? So anytime you have a whole number or an integer, and actually this is an integer, you're going to have, it's automatically rational. Okay, because it doesn't even have a decimal. So it's technically a terminating decimal because it wasn't even there. And so as long as it's terminating, it can be written as fraction. Next guy. Oops. 4.41 equals 2.1. Same thing? type it in right? I did. So, what type of decimal is that? So it's a, yeah, the number system would be rational. Yeah, you're right, rational. Because, why is it rational? It's terminating. Oh, thank you. Silly me. Thank you. Now, be very careful. The next one. First of all, is it terminating or non-terminating? Non-terminating. Is it repeating? No. It has a fancy, cute pattern that's really fun to look at, but a pattern is not the same thing as repeating. So it's non-repeating and non-terminating, meaning it is irrational. All right, so this guy, put him on a number line. I think we can skip that. You guys know how to put things on a number line? Do you want help? Should we do it together? Let's just do it. So when we put on a number line, you're going to have to type it in your calculator to get a decimal approximate. Make sense? So square root of 14, it's approximately 3.7. So we're going to find approximately 3.7 on here, and that's where we'll put root 14. Ooh, where does that next one go? Before the root 14 or after it? Definitely before. It's 3.14, yeah. There's pi. This was 3.7 something. Root 80. .94. So really close to number 9. And 2 root 15. So if you want to type in 2 root 15, you write the 2 first, then the square root, and then the 15. So that's 2 times root 15. That's what we're doing here. 7.74. Dot, dot, dot. So approximately right there, I guess. 2 root 15. And last, square 0.3. Oh, dot, dot, dot. So that's going to be small. Really close to 0. Okay. So I'm going to show you how to convert repeating decimal to a fraction on your calculator. So if you have, hopefully you have, well, if you have scientific, I'm not sure. I don't know. You might have, it's a case-by-case basis, based on which kind of type of scientific you have. So what you would do on a graphing calculator, if you have your graphing calculator, is you need to type in a whole bunch. Like if I'm typing in 0.36, you can see what they're doing here. We're doing a whole bunch of 36, 36, 36. At least 9 decimal places after right? Because that's what your calculator kind of registers as non-terminating. So you want to type in, if it's 0.36 repeating, you want to do a whole bunch of times. Okay, at least 9. And then we want to do something called math. We want to push the math button because we want to change this to a fraction. So this is a great thing. You're going to love this. You'll use this every day. So the math button and number 1 says fraction. You push 1 or just push enter. Math, enter, enter. This will change it to a fraction for you. 4 over 11. So if you use scientific, depends on your scientific. I'd have to look at it case by case. I'm not sure. Yeah. Okay. So let's try the next one. 3.95 repeating. So would I type 95 or 95555? Yeah, good. Just the 5 is repeating. So we're going to type that a whole bunch of times. That's probably enough. And then math, enter, enter. Enter, enter. Okay, did you all get the same thing? 178 over 45? that's going to be handy. So you can change decimals to fractions. Yeah. It automatically is lowest terms. Yeah, your calculator will automatically reduce it, which is wonderful. Okay, we're skipping this. We're not algebraically doing it. As long as you can do it with your calculator, I'm a happy camper. Okay, so moving on to lesson 4, we're going to look at the rest of the number systems. So we need to go through, so we already talked about rational and irrational, right? Let's talk about the rest. So the smallest set is the natural numbers. So I'm going to add just, this drawing is kind of the same as what I had on the board right here. I'm going to start there. So the smallest number system is the very first one you learn, and that's the natural number system. So that's inside here. Okay? So natural numbers are your counting numbers. They start at, you can see it above. Where do they start at? 1, 2, 3, right? That's the natural number system. There are no decimals inside that. Okay, and natural numbers are inside rational because they can be written as fractions, right? Their decimals are non-repeating, and there is no decimal, but technically the decimal is terminating. So it's a rational number. The next smallest number system is the whole number. Okay, and that's already drawn on in your book. And so the whole number system is very similar to natural. There's only one extra number added. 0. It's the whole. Get it? Zero is like a whole. It's the whole. So now you know the difference, okay? You're like, which one has 0? The whole has the whole. So that it's only a little bit bigger, only one number bigger than the natural numbers, but that's your whole numbers, okay? And the whole, again, is still a type of rational number. In fact, all whole numbers except for 0 would be natural. And all of naturals are also whole numbers. Okay. So the next one is the integer. Okay. Do they use I or Z? Oh, use I. Good. Sometimes it's used as Z as a letter, but I. If your books use I, so that's good. So the next number system is the integer. Now, a common mistake students make is they assume that as long as it's a negative or a positive, it's an integer. Well, yes, you're right, it includes negative and positive, but only negative and positive whole numbers. So still no decimals, right? So these guys are going to be the set of like -2, -1, 0, 1, 2, and so forth. Okay? So all natural numbers are also whole numbers, they're also integers, and they're also rational numbers. Right? That's why it's embedded inside of it. Because if you can see, if natural, it's already inside, natural's also inside of the whole. They're also inside integers, inside that box. It's also inside the rational box. Okay? So when you look at these 3 sets, natural, whole, and integers, have no decimals or fractions, right? Other than their simplified whole number that they are. Okay. So that's the real number system. Oh, we forgot to, let's add in the Q and Q naught. So rational and irrational, that's not in your book yet. I didn't write that in. So we don't study non-real numbers, we only study real numbers. The symbol for real numbers is R. And so all rational and irrational are inside of that. Okay? So it'll help having this up on the board as we go through these examples. Because each one we want to say, it says, for each of the following, write all the number sets it belongs to. Did I skip a page, or we're just next page, right? Okay, good. Okay, so number 9, you want to work from the inside out. Okay, so number 9, what's the first set it belongs to, the smallest set? Natural. So it's a natural number. If it's a natural, it's also automatically a whole number. It's also inside of a integer. It's also inside the rational, and everything is inside real. So natural, whole, integer, rational. If you have a natural number, it automatically is in all 5 of those. Okay. 11 over 7. So right away I see a fraction. So if you see a fraction, that excludes these 3 sets. Automatically, if it's a fraction, it's going to be either irrational or rational. That's it. Because these guys do not include decimals or fractions, right? So, is he rational or irrational? What? Rational. Is that what you said? Rational? Why is it rational? What's the definition of rational? Can it be written as a fraction? Can it be written as a fraction? It is a fraction. So therefore, it can be written as a fraction, a over b, because it is a fraction. This is a fraction. A over b. Okay? So yes, it's rational, because by definition, it fits perfectly. If it's rational, everything actually will fall into also real. They'll always be real, every time. And they'll always be either rational or irrational. You'll always at least have 2 or more. Yep, 2 or more. Always be 2 or more sets. Okay, root 5. Is that a perfect square? No, it's definitely not. So what happens when you take the square root of 5 and you write it as a decimal? Meaning rational or irrational? Irrational. It's non-terminating, non-repeating, cannot be written as a fraction. If you want to check, math, enter, enter, it shouldn't turn it in. It can't. So it can't turn into a fraction. Okay? So it's irrational. Oh no. Go back. Okay? And automatically it's also real. All of them have real. Okay, what's the first set or the smallest set that -7 fits into? Smallest one he fits into. So is it a natural counting number? No. Is it a counting number including 0? Is it an integer? Yes, it's a negative whole number. So it's the smallest set is integer. And if it's an integer, it's also automatically it's inside rational. And then automatically real. Got it. So it says, explain why 9 belongs to 5 sets, but -9 only belongs to 3 sets. Because of the negative, right? An integer. So a positive 9 is also a whole and natural number. -9 is only an integer, right? So I don't know if we need to explain that so much. It's okay. So coming up in the next week, we're going to be working with your perfect squares and perfect cubes. Now I know your perfect cubes are probably new to you. It's not something you've memorized in the past, like 4 cubed, 5 cubed, right? You're going to want to memorize that coming forward. But for sure, know your squares, at least up to 12 minimum. Okay? You need to know your perfect squares. We're going to get into radicals, simplifying radicals. And in order to simplify a radical, you have to know your perfect squares. I mean, you can automatically figure them out and make a chart for yourself, but you'll be a lot quicker if you have them memorized. So what this question is asking us to do is estimate the value mentally. So if I look at root 46, where will it lie? Between what two whole numbers? Between 6 squared and 7 squared. Between 36 and 49. I'm probably closer to who?
36.
No, closer to 49.
Yeah, that's what I thought.
So we know it's between, the answer will be between 6 and 7. If you know your perfect squares, because it's between 36 and 6 squared is 36, 7 squared is 49. So it's between those two numbers. Now, in your calculator, what I want you to practice is typing in some of these. I'm not so much worried about the estimation. So let's do B together. Let's actually type that in and get the answer. Because you need to practice typing in some stuff. Okay, so 2 root 18. Now, there's two types of calculators out there. Okay, some of you might have like an 83, like the older versions of the calculators. And if you do, yours is going to look like this. It's going to be, you'll see 2, and then you'll see a square root symbol, and then automatically it opens a bracket. Does anyone's calculator do that? Yes. Okay, so when you do that, oops, let's go back. Nope. I'll find it. There we are. Okay, so when you type that in, you want to put the 18 and then close the bracket because you're closing the square root. Then plus 5 square root bracket 37 and then close the bracket. Okay? Now, the rest of us, yours should have a blinking arrow. You see that? So in order to get out of the square root, you have to push the right arrow. There is no brackets on this version. Okay? Plus 5 square root 37. And technically you can just push enter at this point, or you can push right arrow if you want to get out of the square root. Okay? And there, you should get 38.899 ... Did you get the same thing? Okay? We're going to type in some different stuff right now. Now, negative root 5. You will have an issue if you ever try and do this. Minus sign, if you try to do a minus sign first. Because your calculator does automatically your answer minus. So your previous answer, minus. So you need the negative symbol. Where's the negative symbol? Beside the decimal below 3. So negative, then your square root, and then 5. Okay, that's pretty basic. But there is a difference between the negative and the subtraction. Okay, here's a fun one. Square root of square root 95. Oops, that's... Okay, so you're gonna push square root twice. Square root, square root. And if you have the other version, you'll have square root bracket, I'll type it down here. Square root bracket 95, and then you have to close 2 brackets for the 2 square roots. Okay. And with this one, just like that. So you're square rooting the square root. Just 3.1. You should get 3.12 ... So good so far? I want you to try a couple other ones.